Hey guys, in this video we're looking at transition metals. We'll be looking at what they are, their characteristics as metals, as well as some of their special characteristics. So stay tuned. Let's get straight to it. The transition elements, or also known as the transition metals because they're all metals, are located in the sort of valley in the periodic table. You see the center portion of the periodic table from group 3 until group 12. This is where the transition elements are located in the periodic table. Now let's zoom out. Zoom in. So let's look at them. Now, transition metals are what we typically know as metals. When you think metals, I'm sure if you study group 1, you wouldn't have heard some of the metals there until you learn group 1. Whereas for the transition metals, these are your everyday metals. If you notice, iron is here. Iron is one of the most abundant metals on earth, and it is the most widely used metal. So when you associate your mind with metal, you're actually most likely associating metal with iron. So transition metals are your typical metals. Later we'll compare them with group 1. Let's see some of the familiar metals here. Titanium is transition metal. Then chromium, manganese, iron is here. Platinum is here. Gold, silver, zinc and copper. So all these typical metals, they are actually located in the transition metals in the periodic table. So let's look at their general characteristics. First of all, they are metals. So if they are metals, all metals are good conductors of heat and electricity. That is for sure. And then these metals have a high density. Later we'll compare with group 1. Transition metals have high density, high tensile strength and high hardness. That's why they're used to make many things that we use in our daily lives. Even my mic stand here is made from metal, glasses made from metal, right? So many metals. So the transition metals are used for these things because they have high hardness, high tensile strength, and they have a shiny surface. Remember, gold and silver are also part of transition metals. So when you think shiny surface, normally we think gold or silver, right? And of course, all the other transition metals are shiny as well. And they only become dull if they react with air. Right, so generally they have a very shiny surface. They are ductile and malleable. And ductile is the property of a metal that makes it possible to pull the metal into wires. So to stretch it out into thin wires, that is ductile. Malleable means we can hammer the metal, flatten it, and make it into different shapes. For example, a metal vase. So the property of metal being malleable enables us to hammer it, make a metal sheet, and then shape it into a vase that is malleable. Generally metals have high melting point and boiling points. Let's compare the transition metals to group 1 now. Look at the melting point. So melting point of group 1 metals is generally low, relatively low compared to transition metal. Transition metal melting point and boiling point is much higher than group 1 metal. Density of group 1 metal is relatively low, even though it is a metal. That is why I say when we think about metal, most of the time we are associating it with transition metal. We don't think of metal and think, oh, group 1 metal. No. So group 1 metals have low densities. Remember that sodium, potassium and lithium can float on water. If you haven't seen my video on group 1 metals, it's at the corner. So the transition metals is very high density. Obviously, when we think about putting a metal rod in water, we expect it to sink. Then they form colored compounds. Transition metals form colored compounds mainly, not all, but a lot of them do. Whereas group 1 metals will only form white compounds. The reactions of group 1 metals we already learned is very reactive. Again, check the corner link in the corner if you haven't seen it. Group 1 metals are very reactive, so their reactions are very vigorous. Whereas transition metals, they are not very reactive. Most of their reactions are slow. Some of them are even unreactive. Gold and silver are among the most unreactive metals, and platinum. So they are right at the bottom of the reactivity compared to all other metals. Hardness, okay, this is another one. Generally, when we think metal, again, we are associating metal to most likely iron. So iron is very hard. It's a hard metal. Whereas in group 1 metals, they are very soft. You can even cut the metals with a knife. Okay, group 1 metals can be cut with a knife. Now let's look at the special characteristics of transition metals. So these are specific only to transition metals. Now, number one, they act as catalysts. Catalysts are chemicals that speed up reactions by providing an alternative pathway with a lower activation energy. They lower the energy needed for a reaction to happen, basically. Okay, we'll cover that in detail in another video. So, transition metals can act as catalysts. And here are some examples. Vanadium 5 oxide. Vanadium 5 oxide is used in the contact process. The contact process is the production of sulfuric acid. And then we have iron. Iron is used in the Haber process for the production of ammonia. Nickel is used in hydrogenation in the production of margarine. Platinum is used in the Oswald process for the production of nitric acid. So these are some examples of where these are our transition metals and where they are used. They are used in many industrial processes. So this is very important. This is a very important use of the metals because they save a lot of time and a lot of energy, right? Another special characteristic of transition metals is that they form colored ions as well as colored compounds. But let's look at colored ions first. So whenever they are in aqueous solution, that means whenever they are dissolved in water, then these ions will show a specific color. So copper 2 ion will be blue in color, nickel 2 ion will be green in color, iron 2 will be green, iron 3 will be brown. Now these are very popular ions that are used in the lab, so it is good for you to be familiar with these colors. And then we have our chromate. Chromate is yellow color, dichromate is orange, chromium 3 is green, manganate is purple. These are important as well, and they will be studied more when we study oxidation. If you want to learn about oxidation, the link is at the corner. So here, the color is important because it enables us to recognize that a reaction has taken place, or it enables us to identify. What is the metal ion in a certain compound. If you want to know in detail, again, we'll cover that in a different video. Since they are colored ions in aqueous compounds, they also form colored hydroxides. So these colored compounds, so let's say earlier, copper will form a blue solution, but sometimes the blue is very light. It's very pale blue. It's not very visible. What we can do is, that's because the concentration of copper ions might be too low to be visibly blue. Then what we can do is we can add hydroxide. So we can add sodium hydroxide or we can add potassium hydroxide, and then we have a metal hydroxide being formed. And these metal hydroxides, the color is much clearer. So we will get a blue metal hydroxide for copper 2 ion. Then if we add sodium hydroxide and we find it to be green, then we know either nickel or iron 2 ion is there. Most of the syllabus of SPM and IGCSE, we focus on iron 2 ion as the green hydroxide. And then brown, if the hydroxide is brown, then it is iron 3 ion. Now, another special characteristic is that they have several oxidation numbers or oxidation states. I have a separate video on oxidation numbers. You don't have to worry too, but I'm not going to go into detail in this video. So here the point is that transition metals can have several oxidation states, not just one. So let's look at these copper in these two compounds here, two different compounds. So we have copper 2 oxide and copper 1 oxide. The oxidation number or the oxidation state means the same thing. Of copper in copper 2 oxide is +2, whereas in copper 1 oxide it is +1. So copper, the transition metal, has two different oxidation states here in two different compounds. Let's look at iron. Then we have iron 2 sulfate and iron 3 chloride. Now the oxidation number of iron in iron 2 sulfate is +2. The oxidation number of iron in iron 3 chloride is +3. Notice the iron can have two different oxidation numbers. Then we have the metal here is chromium. The transition metal here is chromium. So chromium here exists as potassium dichromate 6. So the oxidation number of chromium in potassium dichromate 6 is +6, but the oxidation number of chromium in chromium 3 chloride is +3. Again, different oxidation numbers. Then another popular one is manganese. Manganese is very popular. Potassium manganate 7. Here we have manganese in the compound. So the oxidation number of manganese in potassium manganate 7 is +7. The oxidation number of potassium manganate 6 is plus 6. The oxidation number of manganese in potassium manganate 6. Then the oxidation number of manganese in manganese 2 chloride is plus 2. Manganese 4 oxide is plus 4. So again here it displays multiple oxidation numbers. Another special characteristic is that it can form complex ions. Now these are not your regular ions. These are, you will learn them later when you learn about ligands. So here, copper here is the transition metal. So copper can form a complex ion known as tetraamine copper. Tetra is a prefix meaning 4. So here we have tetraamine, 4 molecules here, NH3 molecules attached to copper in the center. So the transition metal will be in the core, and then there will be other molecules surrounding it. Altogether they form a complex ion. And then we have hexaamine chromium. Hexa is for 6, again amine, and then chromium. So chromium is in the center. Hexacyanoferrate. Hexa again for 6. Cyano is for CN group here, CN. So hexacyano 6CN ferrate. So ferrate 2 means iron 2 is at the center. Iron 2 is at the center and it is surrounded by CN, cyanide molecules. And then here we have hexacyanoferrate 3. Again, same thing, but in the middle, at the center is iron 3 instead of iron 2. That's it about transition metals. I hope you've learned something. If you have, please click the like button. If you haven't subscribed, please subscribe for more videos. See you at the next video.